Welcome to Chaos Cortec. Hey guys, welcome back. In this video, we're going to take a look at creating this R2 unit right here. If you've not watched the first video where I just kind of give an overview of this, go back and watch that now. I'll put an annotation somewhere around here and a link down in the description. So go watch that. Make sure you check that out because there's also a survey in there that will let you guys choose what I do for my next project. Now I'm going to give a little disclaimer at the beginning of this. If you are planning on building this, one, I'm sorry. Two, make sure that you are pretty adept at electronics because you're probably going to have to come up with some of your own solutions for this because this is not a fully functioning robot yet. I ran into a few issues while making him. Mainly, the biggest issue I ran into is that his motors that I chose to control his legs are just not powerful enough. They don't have enough torque to actually turn him very well. I got it to run a little bit, but not consistently. And then this is really one of the first big 3D printing projects I've designed, so getting his body together can be a little tricky. It is possible, obviously, but it's not hard, or it's not easy. So if you're up for a 3D printing challenge and are pretty good with electronics, then go ahead and tackle this. Just be prepared to make some modifications. And I will show you how I put it together and give some tips and stuff for what I'm going to do in the future to make this better. Just be aware that this is not fully complete yet. So don't judge it too harshly. And also, since I wasn't able to get it completely running and give a nice detailed tutorial on how to do it, I will be providing some altered models for this. So you'd be able to print this without the electronics and stuff, and it'll just snap together rather than screw together, so you could scale it and just have a nice looking R2 unit to either give as a gift or just have on display somewhere, because it does look really cool. If you have any questions throughout this process, feel free to leave a comment. I will try to reply as quick as I can. And then make sure you subscribe, because I will have more projects like this coming up, and I'll keep you guys up to date throughout the process. Okay, let's get started. Alright, so here we have all of the parts for R2D2. They are completely printed. Well, and this isn't even actually all of them. This is all the major parts. There's a couple gears and stuff I haven't printed yet. But I'll just run through what each piece is and what it does for him. First of all, we've got his head. Now this took about 5 hours to print. And this is just the outer shell for his head, and there's a hole right there that we can put an LED through. This is the body, and holes for the arms or legs, whatever they are, and then some structural stuff for the electronics and whatnot. This was a beast of a print. It took 9.5 hours to print this. Alright, and then this is his butt. I don't know if that's actually what it's called, butt plate. So you can kind of see what he's gonna look like there. And this is one of his legs. And then here is one of the feet, and they just go together like this. And then over here you can see all of the gears and stuff that will go inside of his feet. And this is what will hold all of those gears in place, and these little rods connect through those holes to hold the gears. So these are all of the main parts. Now I'm going to hand them over to my wife to paint the details on them, and then we'll come back and talk a little bit about how she did it. So while she's painting that, let's talk for a second about what I used to put him together. I used these nuts and bolts, and I just got these at a local hardware store. They are Sontax, it looks like, brand. And they are, I think these are number 8 sized, and these are number 6. And these are the ones I use right down here. So these little nuts and bolts. I'll put links in the description to where you can find these. And I think I found this exact one online, and then there's another one that might be more readily available on Amazon. So look for the links down there, and you're going to need quite a few of them. I think the total came to about, well, a little more than 30, I think, so buy ample amounts of these. Okay, so my wife finished painting these. You can see them right here. Here's the body. Looks really nice. The legs. And then the other pieces we've got here. Alright, and finally, this is the head. And basically what she did was take a white plastic primer and coat everything just to help the paint stick and to help give it a more uniform kind of look than just the 3D printed filament. And then she went over it with acrylic paint, and that's where you see like the silver look and stuff, and the blue and the gold for the wires over there. And then after painstakingly doing all of these details, she put some clear coat on it just to help finish it up and help protect against any scratches or chips that might occur on the paint. Okay, so when I designed this, I designed it to go together with these nuts and bolts here. There are some places where there's just two pieces of plastic and you can just screw them together and they'll be fine. There are other places where I wasn't able to do that, and you'll just have these kind of recessed things, and it'll be going in this way, so there's nothing actually holding the nut there. So but these tolerances are pretty tight, so you know the nut should fit in there and sit pretty well, but we just want to make sure that it stays. So I'm just going to use some crazy glue, and basically I'm just going to go around the outside of this, then place this in there, let it sit, and then that way it should stick a lot better and we won't risk him falling apart. Now the places you're going to have to do this, on these arm connector pieces, this is what connects the body to the legs or arms, whatever. You'll notice that one is indented. So don't do that one, and don't do the one straight across from it. But these two, put them there. You can see I've got one in here. So just do the one, those two, and there are two of these arm connectors. Then on the leg pieces, you've got two down here that you need to do, and then two back here. Same thing with the other leg. So on his butt piece, you just have 4 around the edges. And this piece connects the third leg, or the middle leg, to his body, or the butt piece. So you've got 2 down here, and then 2 right here. Then on each of his feet pieces, there are 2 slots right here that will help hold the gears in place here. So you need to do those as well. And I think this is the last one. This piece is to connect, or to hold his head on and allow the servo to rotate it. So you need one right up there. So I'll get all these glued in, and then we'll let it sit and come back and start putting them together. Okay, so now that we've got the screws in, let's start putting it together, and I'm just going to put enough together that I can test out the electronics and make sure my gears work correctly. So first, I'm going to take the body here, and then I'm going to take these little arm connector pieces, and how they fit on is you just basically take these screws and line them up to these holes in here. And this is kind of a tight fit, so make sure they're lined up and then just pop them into place. Then you just have to make sure that these screw holes line up the best they can. And then it's actually time to put in our screws. So for this, your screwdriver needs to be decently long, just so you can get in there a little bit easier. And having a magnetic one will help too. Okay, so there are the arm things. Now you want to make sure that the indented one, is facing the top, because otherwise your screw will protrude and block the gears. Okay, now what you're going to want to do is find your piece like this, with this attached, and then get this piece right here, just the little bevel gear that has the slot in it, and then take one of the legs, and then you put this in there just like so. You can see where the angle's going there. And then you take this and slide it right through here. Now this part can be a little tricky, so just try and line it up the best you can. Okay, so then our next step is to take one of these legs here and attach it to one of the feet. And basically what you want to do here is you can see that they match up like this. So the battery pack right here faces the inside, or the battery pack right here is on the same side as the flush white side here. And then you just want to make sure that these wires right there face the inside angle here, like so. Okay, and now you can kind of see how this lines up, but it basically will just go on like so, match up the big hole with this big hole, just like this, and then come back to the bottom here, make sure everything's lined up, and then you can see right down there is where we need to connect it. And the ones we are screwing in are the two side ones here. Okay, so that's what it should look like. And just remember while you're doing this, do not tighten those too much, because one, you can break the plastic, and two, it could separate the glue, and you don't want that. So, I mean, they can be tight, just don't over tighten them. Okay, so the next piece we take is this one. These connect just like this. So you can see that the two nuts line up that way and the hole is correct. And then on this, disregard the two outside, or the two left and right holes there. Those were just to make sure that these had enough room to come through, which they do. So just lay it down, go like that. Okay, so then if we're looking at it like this, we want the two top and bottom ones. Fuck me. Okay, so when we're done, this is what we should have, and it should actually just sit like that, and then the body will sit on top of here, and this is what actually gives him his angle. So that's it for that piece. We will set it aside for now. Now we're going to start with these pieces right over here, and what we're going to end up building is going to be this, and this is just basically the gearbox for the legs. And so these will be the wheels that he will ultimately drive on, and these gears will help connect to the motors. So what you're going to need is all of these little pieces here that were printed out. You will not need these tiny little guys just yet, so set those aside. And then you will need all of our gears that we printed, and this little bracket thing here. And so I've arranged them, and it's kind of hard to see, but the big wheels take the longest of these sticks, and then there are the second longest go for two of the tiny gears, the two shortest go for two of the tiny gears, and the one mid-length kind of one goes for the odd-looking bevel gear here. And so what we want to do, so we will start with these, and make sure, you can see it's got some gearing in there. Make sure that lines up with this slot, just like so. And then take this stick and just shove it through like that. And that's all you have to do. And just make sure it spins all right. And if it doesn't, just pull this back out and use a file or some sandpaper to grind it down a little bit. Good. Okay. Okay, so there is our finished piece, and you can tell if it works if you can move this top gear here and both wheels spin. And if they do, you're set. One thing to note is these two, the top two tiny gears here, do not penetrate all the way through because they would hit this gear, so they're blocked there, but just push them all the way in and they should be good to go. Okay, so then here's the body, and you can, as you can see, I've already got one of the feet on. And so we will just attach the other one here. Now these can be a little hard to get in, so just make sure they're lined up on the inside too. That's important. Now with the first leg, it's really easy because you can go through this hole, but the second leg, it's a little bit tougher because you have to angle in from the top. So that's where a magnetic screwdriver will really help. Okay, so there we have the legs on the body. That looks pretty good. Okay, so then we're going to put our gears in the foot. Now, look at this little bridge piece here. That goes into this little slot here. So just kind of set that in. And then this is a pretty tight fit, so just push it in the best you can. And then once you have it in, just make sure that the wheels still turn. All right, and then just screw these into place. Okay, so that's what it should look like when it's done. Next step is this part right here, and that's where these pieces come into play. Now, they do overhang slightly on this edge, so pay attention when you're lining up these holes. And that's what these tiny little connectors are for. They will basically just stick right in here, like so. We'll glue them and then glue them to the other part as well. Alright, so that's it when it's done. Okay guys, so now that we've got the legs pretty much put together, it's time to start thinking about the wiring and all of the electronic components in here. So this may look scary, and it kind of is, but it's really not that complicated. I'll just quickly break down what each section kind of is and what the components are. So right over here we've got two stepper motors, and these are what is going to control his legs. And then this is a servo motor to turn his head. Then of course we've got the Arduino right here. This is the brains of the whole operation. Here we've got an LED. It is an RGB LED. And this will be his eye. Well, I don't know if that's really an eye. The light on his head. And then right here, we've got a Bluetooth module, and this is how we will control him. And so this board, while it looks crazy, most of this is just to control the stepper motors over here. So don't be too daunted, and I will provide a schematic for this, or a breadboard layout, and we'll go over it in more detail. So I've got these two boxes here, half boxes, and they go together like this, and they hold the motors inside of them. So basically how these work is they sit sideways like this, and there's little holes. They should fit pretty perfectly in there. And then servo there. I did put in some tabs down here to actually hold some ribbon cable, because I was planning on doing this a lot nicer, and I was going to cut these off, solder them to some ribbon cable, then have the ribbon cable come down and have this all be modular and detachable. But one, I didn't end up getting enough components to do that, and two, I'm running out of time. So I might include a model that does not have this bottom part, so these wires can just come down, and that would be ideal for this. Otherwise, there are little slots down there that you can feed the wires through, and that's what I'll be doing. Then once they're together, you can take this second half here and close the whole thing in, and you have yourself a nice little motor box here. Now, that's all dandy, but the problem is trying to get this into the R2 unit. So, if you have not put together your electronics yet, this is going to make your life easier, but where I have, and I don't really feel like disassembling and trying to rewire all this, I'm going to take the hard route. So these will just sit in here like this, and they screw right there, so the motors will have access to the arms and the head from here. Okay, so just take half of it, slide it in there like so, and then you're going to need these two little pieces here. These are just little bevel gears and a bigger slot attached to them, and they will slide right into the armhole. This is what will connect you to the leg gears. And make sure that they are facing up. That will make your life a lot easier. You know, actually take this out. Don't put that in yet. And these are not held in, so you'll have to hold it like this. Otherwise, it's not going to be easy to do. And then we're going to feed these motors through. Okay, so the next step is you're going to want to put the motors in place in this motor case. Okay, and then we will put the top of the motor case on. Actually, let's get these wires figured out here. Okay, now for the really sucky part. So see these little knobs that stick out? Rotate them so they are facing up and down. I know it seems weird, but it's what I came up with. So take this whole box and make sure that the those little gear things are in there. And then just slide these in, and the gear box, or the little gear slots, should slide into these little slots on the arm gear. Okay, so I'm sure you could see me struggling there. So once again, if you're building this, I'm sorry, I did not think it would be that hard to get in. Now, to make sure that this does not fall out, just take these little slots and rotate them a bit. It'll rotate the stepper motors as well, but that's a good thing. So that way, now we can tip it over and it won't just fall out on us. Alright, here is another pretty difficult part. We need to get the screws into this motor box. Okay, there we go. Hopefully sucking us over. And now you'll notice if you try to turn the wheels manually, they will not move. And that is because the stepper motors are holding them in place. Okay guys, so now, as you can see there, we've got the body pretty much put together. Motors are in place. So now we are tasked with putting all of the electronics inside the body. And for this, I tried to leave a couple different options. I don't know if you can see, but down in, no, you can't really see it. I did put little pegs down the bottom in order to hold one of these guys. And this is just a solderable breadboard. And that's just if you want to make this a little more permanent than just having these plug-in breadboards. And I just got these off of Adafruit, and I will put the links in the description for all this. So if you wanted to transfer it to something like this, you could, and the pegs just go through these two little holes on the side here. So that'd work out pretty well. And then I also included a slot in the back for a LiPo charger for a mini USB. And I mean, really any charger that would take mini USB, there is a slot in the back of the body that will be able to handle that. So I had planned on putting a LiPo in there and kind of powering him that way. And also, if you want to cut down on space, you can remove the Arduino from the mix completely and just use the Atmega chip and put that on the breadboard itself. There is enough room on the breadboard. You'll have to get a little fancy with some of the Bluetooth and the LED stuff, but there is actually enough room on a single breadboard to have an Atmega chip and two motor drivers here, and then everything else plugs directly into pins. So it would work that way. And if you want some more information on how to do, or how to get that Atmega chip out and working on its own, I have a video detailing that too. I'll put an annotation somewhere around here, and I'll also put a link down in the description. And the only reason I'm not putting the LiPo and everything in and doing this and making it more permanent is, as I mentioned before, the motors I'm using are not powerful enough. So I'm going to have to order some more parts and maybe redesign something in there. So he's not quite ready to roll yet. I mean, he is functioning in his current state, just barely. So I will give a little demo of him but I'm not going to go as far as to make him battery running and make everything permanent inside of him, because I will be making changes down the road, adding more features like a speaker so he can make sounds and stuff like that. Okay, for this next part, you're going to need this piece right here, the little servo attachment that comes with this servo, and it just fits right on the top. I used the little plus shaped one, but you could get away with using the straight line one. And basically what we're going to do is just take this and slide it right in there, and this should come up. Okay, so it'll fit pretty snugly in there, and then we just take advantage of that to attach it to the servo head. And then we'll take this piece here and screw them together through those holes right there. And then they just go through right like that, and then you just take the little nut and screw it on like so. And do that for the other side, and then this piece will actually attach to the head itself, and it'll actually hold the LED as well, and it'll allow all that to rotate, hopefully without getting the cords bunched up. Okay, so just place that on there, and a good thing to do before this is to get the servo motor in a known position so you can have R2's head facing forward, because obviously this is going to be the front of R2's head, so you'll want 180 to be about here, or 0 to be about here, and 180 to be about here. So at about 90 degrees he'll be looking forward. Okay, so once you have all the electronics kind of shoved in there, pull the LED up and kind of wrap it around this, and it should stick in this hole pretty well. If it doesn't, you can use some tape or something to keep it there. And now let's just give it a try, see if we can move it and have it move all right. Looks like it. All right, it's looking good. Okay, so then the only thing left is to attach the head. And obviously this hole right here is going to want to match up with that LED. And then this is a little screw that we can screw into that right there. And this thing will pop off if you apply enough pressure, so just be careful when you're putting it on. You might just want to pop it off anyways and then try and put it back on, but it's going to be kind of hard once you have this on there. Okay, so now the last step is just to attach this. And then before you've gotten it tightened all the way, just line it up. And then tighten it the rest of the way down. So it looks like that's done. Let's power them on and see how things went. Alright, let's have a look at them. That looks pretty amazing. So then if we want to look at the code itself, again, not much happening here. There is a little bit, but it's really pretty simple once I break it down. Right here we have the stepper and servo libraries, so all I'm doing is just including those. And then these variables right here are for the left stepper motor, the pins, and then these are some counters to get it to the right position. And then same thing for the right stepper motor. And then we have some LED pins for the RGB LED. And then we have our variables for the servo. And again, we have that current and goal to kind of keep track of where the servo is at. And for a little reasoning behind why I have those counters and stuff like that, because with steppers and servos, you can set it to go to a specific degree and it'll just go there. Um, but the problem is like with the steppers, you give it a certain number of steps. So say that you want it to rotate 2 full times. It's going to take a decent amount of time to rotate through that. And if you just give it that full amount right away, that is an actual blocking method. So it will completely lock down all of your code and not execute anything until those steps have completed. So, for example, just the 2 motors to drive him, if we did that, the 2 motors would, one would turn finish, and then the other one would turn finish, and then it would continue on with whatever other code we had for like the LED and the servo. So obviously that's not what we want. So instead what I'm doing is I just have a goal that I want it to be at, and then a counter, and then I just move it basically 1 step at a time. And then it just increases that counter until we hit the goal, and then we know it's moved. So now I can move like right motor, then the left motor, and they happen so fast that you can't even tell. They look like they're moving at the same time. And then this is where we're actually setting up our motors. So we've got the steppers for the legs, and then the servo for the head. Then in the setup method, we declare our output pins and start up our serial monitor for testing, and then initiate all of the motors we have. And then in the loop, first of all, we check if the serial is available, and that either means that we're getting some input from the serial monitor or from our Bluetooth module. And then we read that data in and print it back out just for some sort of confirmation. And then what I'm doing here is just checking to see what that is, and I just use the normal computer WASD for movement just for testing purposes, but I never really got past that. So W moves it forward, S moves it backwards, A and D move it left and right. And basically what I'm doing is just setting the goals and the current count to 0. So then down here, this is where the steppers actually count upwards, and once they and as they count, they step, and then once they hit that, obviously they'll stop stepping. And same thing if the rotation is negative, it'll count down. And then I just have some code here that will rotate the head kind of randomly, because R2, when he moves around, his head kind of moves around and his light changes a lot. And it doesn't work very well to have those manually controlled. So I just have him looking every couple seconds. I have his head turn to a random degree, and then the LED in his head changes to a random color. And I just use the random number generator here for that. And then this right here is just a method to change the LED to one of these preset colors. And obviously you can add more colors here, do whatever you want. So that's really all there is to it. And once again, this is not completely tested because I was not able to get those servo motors to work enough to test them out fully. But I did test the head and the LED changing, as you can see in my other video. So that part works. So just be prepared if you do this to make adjustments to this. And I'll put a link to this code down in the description so you can check it out for yourself. Alright guys, so this is what your finished R2 unit should look like. Now if you did manage to build one of these, please make a video or something like that and send it to me. I would love to see it. And then let me know what you did to alter it and make things work for you. Maybe I'll just run through some things that I think I'm going to do during the next iteration to hopefully make this better. First thing, I built it to use these, and maybe in the next one I will leave a little more room in the bottom in case I just want to put the breadboard and Arduino in there, because right now it's built pretty much just to fit this, and fitting everything else inside of it is pretty difficult. And then I think for the motors, I obviously need to upgrade them to something bigger. There are some 12-volt steppers that I found and they have quite a bit higher torque power than these do. So I think those would work. They are a completely different shape, and I think they're quite a bit bigger. So I'd have to redesign the box on the inside to hold them. But with those 12-volt stepper motors, obviously the Arduino runs on 5 volts. And so I'd have to get another power supply and probably have 2 different power supplies, one to run the motors and then one to run the Arduino, which after doing some research, I guess is pretty common in building robots. But I did also find some continuous rotation servos that run on 5 volts and have a pretty comparable torque power to that. And so those might be something to look into as well. And at least with those, it only takes 1 pin on the Arduino to run them instead of 4, like these steppers. I'll put links to those other motors that I found down there, just in case you want to try and rig up something to hold them yourself, then get this going. Because the gears inside of here do work if you have something that can push them the way they need to be pushed. And then also for a future update, I'd like to do something with this middle leg to allow this to roll on carpet. It's just a little hard where he's driven from the back legs. There's potential where this would be sliding left and right, so I can't just have a wheel that goes front and back. So I'd have to come up with something fancier there. And then I'd also like to print some Ninja Flex tires to give him a little more grip on things. Eventually I am going to come back to this, make it better, and get one that actually works to a point that I can provide a detailed tutorial and hopefully get some, and then hopefully give some people that maybe aren't as comfortable with electronics an opportunity to make this. So I think I'll leave it at that. I appreciate you guys watching. I apologize that I was not able to get it fully functional. I just thought I'd put the files out there now, and we'll move on from here. I'm going to take a little break from R2 and maybe do some other robots, and then once I have some more, and then do some other projects, and once I have some more experience, I'll come back to R2 and make him better. Alright, thanks for watching, guys. See you next time. Hey guys, hope you enjoyed the video. If you did, make sure you like, subscribe, and share this video. It helps me out a lot. You can also follow me on Twitter. I'm at ChaosCoreTech. And once you've done all that, check out some of these other videos I've made. Thanks for watching, guys.